Hello, my name is Roda Al-Mulla. I'm 12th grade student from Dubai National School. Today I'll be teaching you about adding and subtracting matrices. So our objectives for today, first of all, to define matrix dimension and entries, and solving adding and subtracting matrices equations. So let's start by formally defining what is a matrix and introducing some basic terms that you need to know. An M times N matrix A is a rectangular array of real numbers. So with M here, M refers to rows and N refers to columns. So when we have M times N, this refers to the dimension of the matrix. I'll show you an example after this slide. And the numbers that appear in the matrix are called entries. So you need to know that M times N, M refers to rows and N refers to columns. Let's have a quick example. So here we have A equals 2, 0, 1, and 33, -2, and 0. So this matrix, we need to have the dimension of it. So first of all, M times N. M, as we said, that M refers to rows and N refers to columns. So let's see, how many rows do we have here? 1 and 2. So 2 and 3 columns. So 2 times 3 matrix because it has 2 rows and 3 columns. And the entries are the numbers inside the matrix are 2, 0, 1, 33, -2, and 0. Row matrix, column matrix, and square matrix. We have 3 types of matrices. A matrix with a single row is called a row matrix. And a matrix with a single column is called a column matrix. And the matrix with the same numbers of rows as columns are called square matrix. I'll show you an example of each one. So here, the matrix is 1 times 5 matrix is equals, see, we have here just 1 row. So it's called a row matrix, but we have several columns. Here, the 4 times 1 dimension here, this is called a column matrix because we have a 1 column, but several rows. And here, when the rows are equal to the columns, we call it a square matrix. Here's an example, 3 times 3, the dimension of this matrix. We have 3 rows and 3 columns. So for adding and subtracting matrices, we have rules. First of all, the first matrix operation we discuss are the matrix addition and subtraction. The rules for this operation are too simple, but you need to follow them. Adding and subtraction can only be done with matrices that have the same dimension. The matrices that have the same dimension, we can add them or subtract them. 2 matrices can be added or subtracted if and only if they have the same dimension, as I told you. To add or subtract 2 matrices of the same dimension, we add or subtract the corresponding entries. I'll show you an example now. So here we need to, first of all, see the dimension of the 2 matrices. If the 2 matrices have the same dimension, then we can solve this. But if if the first matrix dimension are different from the second matrix dimension, then we cannot add them. So first of all, let's see how many rows do we have? 1, 2, 3. And how many columns? 1, 2, 3. So here's the dimension, 3 times 3. And here, 1, 2, 3 rows and 3 columns. So here's 3 times 3. So now we can add them. So we need to add the corresponding elements in each matrix. So here, -2, the corresponding element of it is -4. Same as 0, the corresponding element is 6. 4, the corresponding element is 0. So -2 plus -4 plus minus will be equals to minus. So we'll put it as minus directly. Here, 0 plus 6, 4 plus 0, take each element together. 3 plus minus -15, it will be equal to -15. And then -10 plus 2, 12 plus -4 will be equals to minus. 3 plus 6, -2 plus 7, and -2 plus 1. So we can like solve it mentally, no need for a calculator here, but if you need to check, you can write this in calculator. -2 minus 4 is -6. 0 plus 6 equals to 6. 4 plus 1, 4 plus 0 is 4. 3 minus 15 is equals to -12. We will take the sign of the bigger number as usual, as we know. -10 plus 2 is -8. We'll take the sign of the bigger number. 12 minus 4 is 8. 3 plus 6 is 9. -2 plus 7 is 5. We'll take the sign of the bigger number. -2 plus 1 is -1. So here we have the answer of adding these two matrices. We will have another example. Find the sum. First of all, before finding the sum, before adding the corresponding elements, you need to check the dimension of each matrix. So let's see here, what's the dimension of this matrix? We have 2 rows and 3 columns. So 2 times 3. Same as here, 2 rows and 3 dimensions. So now we can start adding the two matrices. So we need to take each element with the corresponding element of it. So 1 plus 2. 2 plus -1 plus with negative will be equals to negative. 3 plus minus -9 plus and minus will be equals to negative. 3 plus 4, 4 plus 7, and 5 plus 1. See, as you can see here. 1 plus 2 will be equals to 3. 2 minus 1 will be equals to 1. 3 minus 9 equals to -6, because we'll take the sign of the bigger number. 3 plus 4 here. 4 plus 7 is 11. And 5 plus 1 is 6. Now we will have an example of subtraction. Easy and simple. So first of all, you need to see the dimension of the matrices. As you can see here, we have 1, 2, 3 rows and 2 columns. So 3 times 2. Let's check the other matrix here. 1, 2, 3 rows and 2 columns. So we have the same dimension for 2 matrices. And now let us take the corresponding element of 2 is 9. So 2 minus 9, it's -7. -3 minus 5 minus -5 minus and -5 will be equals to plus. So -3 plus 5 is 2. 1 minus 0 equals to 1. 0 minus 13 equals to -13. -1 minus 1, 1 negative with negative will be equals to plus. So minus 1 plus 1 will be equals to what? 0. 3 minus 3 equals to 0. Here's another example of subtraction. Subtraction. 2 minus minus 4 minus with minus will be equals to plus. So here's 2 plus 4 minus 18 minus 2, 20 minus negative 5. We have here the same sign, so equals to plus. Negative 5 minus 1. See, we can write it in this form. Then the answer will be, the answer of minus minus will be equals plus, so 2 plus 4 is 6. Negative 18 minus 2 is negative 20. Same sign, so we will add, but the sign will take the sign of the bigger number. 20 minus minus 5, this means plus here, so 25. Minus 5 minus 1, minus 6, negative 6. So here, let's first of all check the dimension of each matrix. So here we have 2 rows and 2 columns, and here 2 rows and 3 columns. So here we cannot find the sum of this because we cannot add different dimensions. As I told you before, you cannot add any matrix with the other matrix if they are not the same dimension. If you have different dimension, you cannot find the sum. But when you have the same dimensions, you can find the sum of these 2 matrices. Thank you for listening.